Hi guys, this video is talking about solving special systems. Special systems, there's something that occurs that's different than what you have been talking about up to this point. This is part of 3-1, but I just want to talk about it separately. What you've been solving so far, when you just talk about graphing systems of equations, has looked something like this. You have two lines and they cross at one specific intersection point, and that point was the solution. Now, we're not talking about inequalities where you were shading, just talking about equations where the point was the solution. If that is the case, then okay, it has exactly one solution. They're just intersecting lines, and you could tell this because they would have different slopes. The equations of these two lines would be they would be different. This is called consistent independent. I do want you to know this term, consistent independent, and it has exactly one solution, okay? We'll talk about what I mean by different slopes in just a minute. When we talk about the special systems, that really starts here. There's nothing really special about this, it just intersects at one point. But down here, these two different options, this first one just says it's like you've had the same line. You've graphed the same line. And so if you graph two lines that are the same, then at every point it intersects. So there are infinitely many intersection points. So there are infinitely many solutions. It's the exact same line, therefore you would have the same slope and the same y-intercept. The second type of special system is where you have no solution because there's no intersection point. You had one of these on your homework problems. So since there's nowhere that they intersect, there is no solution because the solution means this point exists on both of the lines. So parallel lines, you know already because we've practiced this, that they have the same slope. And if you take a look, they do not have the same y-intercept. This one is here and this one is here. If they did have the same y-intercept, then we would just be back up to this one because if I have the exact same y-intercept and the same slope, I create the same line. Here, same slope but different y-intercepts. So what you can do is there are a couple of methods. One, you can solve the system by doing any of the things that you've learned so far. You can graph, use substitution or elimination. The second method is if you put both of them in slope-intercept form, y equals mx plus b, compare their slopes. If the slopes are the same, notice that in both of these cases the slopes would be the same, and they have a different y-intercept, you'd be down here with parallel lines. If they had the same y-intercept, well, same slope and same y-intercept, you have the same line. So there are two ways that we can do this, and you're just going to have to practice to make sure that you understand. Also, I want you to know these terms: consistent, dependent. Consistent means there is a solution. So in both of these examples here, there is a solution, so they're both called consistent. Independent is when there's just one, and dependent is when there are infinitely many. And then down here, there is no solution at all, so you just say it's inconsistent. Okay, so let's start. I'm going to put y equals mx plus b here for method 2. Let's flip over to the next side and try some problems. All right, so notice that the system that I've given you for both method 1 and method 2, they're the exact same. I'm just going to show you how to solve them differently. I like to do elimination, so what I'm going to do is I'm going to rewrite this first problem in standard form, ax plus by equals c. So I move the minus 2 over, so I'm going to have a 2x plus y equals 5. And then I'm going to rewrite the second equation, 2x plus y equals 1. And now I just need to decide what I want to cancel. They're both positive, so I need to make one of them negative. So I'm going to just cancel by making them all the opposite signs. So this turns into negative 2x minus y equals negative 1. Okay, so now this doesn't exist anymore, and I am adding together these. So when I combine 2x and negative 2x, well, that cancels and makes 0. Y and negative y, well, that cancels and makes 0. So on the left side of the equal sign, I have 0. And then I have 5 and minus 1, which is 4. And then you say to yourself, well, does 0 equal 4? No, that's not true. 0 does not equal 4. Since it is not true, then this would be no solution. Now, in the cases where we solved for x, plugged an x in, and got a y, that would, if you can get an x and you get a y, there would be one solution. But if it turns out like this, there would be no solution. Now let's try this using the second method. So put them both in slope-intercept form. This one's already written in slope-intercept form. I'm just going to rewrite it over here. Negative 2x plus 5 there. And then I'm going to rewrite this one. Y equals, move the 2x over, negative 2x plus 1. Now I just want to compare. If you look at the rules of method 2, it says compare their slopes and compare the y-intercept. The slopes are both negative 2, so they have the same slope. And then you look at where they start, what the y-intercept is. Their y-intercepts are two different values. So if I were to look at how this looks on a graph, if I had to start at 5 and I had to start at 1, but my slopes are the same, I am creating parallel lines. Okay, so these parallel lines means that there is no solution. Same slope, different y-intercept, no solution. Okay, again, same problems here. Method 1, I put them both in standard form, and you can use substitution if you'd like, since this is not in standard form. It doesn't matter to me. I just really like elimination. So I'm going to move the x over, and I'm going to say negative x plus y equals negative 3. Now, I'm going to leave that negative x there instead of making it a true standard form. I'm going to leave it negative because it might automatically cancel for me. So x minus y, and get this 3 to the other side, positive 3 over there. When you move this to the other side, it becomes positive 3. Okay, now we start to combine our terms. So negative x and a positive x cancels. A positive y and a negative y cancels. So I've got 0 on this left side. Equals a negative 3 and a positive 3 cancels. Okay, so that's 0. Anytime you get a true statement, let's just say you had 5 equals 5, 7 equals 7, negative 3 equals negative 3, 0 equals 0. If it's true, that means there are infinitely many solutions. So infinitely many solutions. This would also be called consistent dependent, whereas this one up here would be called inconsistent. Okay? Okay, now let's check this using the second method. This should say method 2 here. Okay, so put them both in slope-intercept form. The first one has been done for you. Y equals x minus 3. The second one, y equals, negative y equals, move the x to the other side. So we have negative x, and then move the 3 to the other side, plus 3. But I need to get rid of negative y because slope-intercept form is y equals, not negative y equals. Divide by negative 1, divide by negative 1, and we'll have y equals negative divided by negative is positive, so x, and then minus 3. All right, so this is done. I want to be able to see in between here. Now take a look. They look exactly the same. The slopes are both understood to be 1. The y-intercepts are both at -3. Same line. Same line here. They have the same slope and the same y-intercept. Therefore, this has infinitely many solutions. Again, this is consistent, dependent, and up here this was inconsistent. So that's all for special systems. Make sure you ask me any questions that you have.